In computer graphics, especially with recent advancements in deep learning and generative models, datasets are essential. They help in training, testing, and improving new algorithms and technologies. This is also true for character animation, where well-known datasets like AMAS and Human 3.6M are used for motion analysis and synthesis. However, these datasets mainly focus on human poses and don't include other types of data beyond skeletal information. Recently, there has been a shift toward multimodal datasets, which combine different kinds of data. However, current datasets still mainly focus on just a few input types like audio, video, and text-driven tasks. Collecting multimodal data for character animation is difficult, and only a few datasets partially include such data. This is even harder when it comes to recording musical instrument performances, which require capturing body movements, facial expressions, finger positions, audio, video, and symbolic data like MIDI. The challenges include different instruments need different methods for capturing and calibration, adding to the difficulty. Synchronizing all the data requires specialized tools and techniques. Instruments involve subtle movements, like facial expressions and finger motions, where even slight differences can affect the quality or tone of the sound. Objects like drums can block the view of the performer's body, making it hard to capture everything. Musical performance datasets have improved to include more comprehensive data, but significant gaps remain because they are mainly focused on music information retrieval tasks. Early datasets lacked body movement data, while later ones included upper body motion, but missed finer details like finger and facial expressions. Recent datasets now capture finger movements, which are crucial for instruments like the guitar and violin, but facial data, important for capturing performer expression, is still often missing. As datasets become more complex, they tend to have fewer samples and more access restrictions. Many are hosted on platforms that are not easy to search, and the motion capture data often needs more processing before it can be used. To address these gaps and support further research, we introduced the Multi-Modal Instrument Performances database. This dataset captures detailed musical performances with multiple synchronized data streams. It includes high-quality 3D motion capture of the musician's body, fingers, facial expressions, and instrument, along with synchronized audio, multi-angle video, and MIDI data. So far, we have recorded 3.5 hours of performances on piano, guitar, and drums. Our dataset offers rich multimodal data that can be used in fields like deep learning, character animation, computer vision, and music research. It can facilitate tasks such as audio-to-animation synthesis, audio-to-MIDI transcription, and performance analysis for injury prevention. To capture these performances, we use several devices. In this video, you can see a motion capture session of a piano performance. We use the Rococo Full Performance Capture System, which includes a bodysuit and gloves, to capture full body motion. For the face, we used a head-mounted rig with an iPhone to capture facial expressions. We also enhanced the precision of 3D tracking using the Rococo Coil Pro system, which uses electromagnetic fields to improve movement tracking. Specifically for the guitar recordings, we added a 24-camera optical motion capture system with active LEDs to track the guitar's movement, which was not needed for the other instruments since they do not move. Audio and MIDI were captured using Reaper and a Focusrite Scarlett 2i2 interface. We also used 5 cameras to capture video from multiple angles. Our database features a variety of instruments, including strings like the guitar, digital piano, and percussion like drums. To enable data acquisition, we invited professional musicians with extensive experience and expertise in performance and composition to record in our studio. Upon arrival, the musicians reviewed and signed an informed consent form, acknowledging their understanding of the study and agreeing to participate. Before the session, we took the performers' body measurements according to Rococo specifications. We gave them time to warm up and adjust to the suit to ensure comfort during the performance. For instrument calibration, on the piano, we calibrated by pressing the first and last keys. For drums, the drummer played a sequence to map the drum set. For the guitar, we used the phase space optical motion capture system to track its movement. To synchronize the motion capture data with the audio, we used a Python script to start recording room audio simultaneously with the motion data. Both audio and MIDI were captured within the same DAW project on separate channels. For synchronizing video with audio, we utilized DaVinci Resolve's automatic alignment tool. This tool matches the audio waveforms captured by the video cameras with the room audio from the Reaper, enabling precise alignment. During the recordings, musicians performed to a metronome or backing tracks to keep a consistent tempo. Room audio was captured with a high-resolution microphone and recorded in Reaper, along with direct audio from the instruments and MIDI data for piano and drums. Video was recorded using 4 cameras placed around the performer, plus an overhead camera for drums and piano, all in 4K at 60 frames per second. In total, we collected 3.5 hours of high-quality musical performances. Here is a raw motion capture example, prior to any cleaning or post-processing from our recordings. And here is also a raw motion capture example from piano recordings, retargeted to a character-creator character for visualization purposes only. Our repository interface has been designed to provide a range of features that enable users to easily navigate, locate, and retrieve the precise data they need, using filtering and sorting based on metadata. Users can choose to download individual files, specific performances, or the entire collection. Moreover, hovering over specific cells in the interface reveals additional metadata, such as the performer's body dimensions and key musical features of the piece. The platform provides inbuilt tools for easy visualizations, enhancing accessibility prior to downloading the data. To further facilitate the exploration and analysis of the dataset, we provide additional tools alongside the data. First, the FBX Player tool allows users to play back FBX files synchronized with audio directly in a web environment, eliminating the need for external 3D software or downloading the data. Finally, we provide the MIDI-to-instrument animation tool. This tool generates 3D animations based on MIDI data, accurately showing the notes played. It can be used with automated systems like inverse kinematics controllers to create realistic representations of the performance. Thank you for watching.